Hi guys, welcome back to my channel. Today we are doing minimum size subarray sum. So we're given an array of positive integers nums and a positive integer target, and they want us to return the minimal length of a subarray whose sum is greater than or equal to target. If there's no such subarray, they want us to return 0 instead. So we're given an example down here where nums equals this array and target equals 7. And basically what we're doing is so we'll start with this, just like the very first element, 2. Since 2 is less than 7, we want to keep adding elements from the right side until it is equal to or greater than 7. So we'll add 3, that's still less than 7. We'll add this 1, still less than 7. And then we'll add this 2, and then that gives us 8, which is greater than 7. So because 8 is greater than 7, then we'll want to remove elements from the left side until it is less than or equal to 7. So if we remove this 2, then that will give us 6 here, which is less than 7 again. And then because it's less than that, we'll add elements from the right side. So we'll add this 4, that makes it greater than 7, so we'll remove the 3. And that's our new window, and then so on, until we either find one that equals to 7, or we find nothing and then we return 0 instead. So this is just a classic sliding window problem. So we'll need a left pointer to track the index of where we're at on the left side, so int left equals 0. And we'll need a right pointer to track where we're at on the right side, but I'll do that with a loop in a minute, so I'm not going to do that yet. And then we need to keep track of the current sum of our window. So like if this is our window, then we need to keep track of the sum of this, which would be 3 in this case, but because it's always changing, so we need a variable for that as well. So we can say sum equals 0. And then as our window changes, we want the minimal length of the subarray that would work. So we also need to keep track of our minimum, which we can initialize to integer.max value. That way, like, there will never be anything bigger than this, and everything, like, it'll always just get like rewritten. So okay, now we can start our loop because we want to loop through nums to check our windows. So, and this is where we will start our right pointer. So right is 0 in the beginning, right is less than nums.length, right plus plus. Okay, and then in here, so immediately, because right is index 0, we want to add this to our window. So we can add the value to our sum, so sum plus equals nums.right. Okay, and then we want, so like then while our sum is greater than target, which it's not in this case, but it could be, like if this was like 9 or something, right, then we would want to remove elements from our left index until it satisfies this requirement again. So, and our left is also at index 0 right now, so it would actually just remove this element. So we can say while sum is greater than or equal to target, and we also need left to be less than or equal to right, actually, because we don't want the left index to, like, if this is our right index, we don't want the left index to be going like all the way over here, right? So we also need that check. Then we'll just well, first of all, we will update our minimum to be either our current minimum or the, like, whichever one is smaller. So whether our previous minimum, or the new minimum, our current length, which would be right minus left plus 1. And that's because, like, this is the right index minus the left one plus 1 is because, like, this 1 makes it inclusive. Because if we just do right minus left, then that's exclusive, not including the right element. So, like, I'll give you an example. So, like, let's say our minimum window is like let's just use this one, so it's like more simple. Like, let's say it's from 4, like this 4 to this 1 or something, then that would be index 0, 1, 2, right? So 2 minus 0 gives us 2, and then this plus 1 would make it 3, so that because we have a length of 3 here. So that's why we have this plus 1. And then we want to update our sum to delete elements from the left side. So minus equals nums at left. And then we need to increment left so that every time we remove an element, then left is moving up. So yeah, that's gonna be it for checking our windows. And then if we loop through all of nums and we don't find anything, then that means our minimum will still be integer.maxValue because it was never rewritten. So if that's the case, we found nothing, then we want to return 0. So if min is integer.maxValue, return 0. Otherwise, we'll just return min. So let's check that. Okay, perfect. So the time complexity for this is going to be O of n. And that is because, like, so I know it can be kind of confusing because we have this for loop and this while loop that's inside the for loop, but it's because the while loop gets like amortized, which basically, like, because if you think about like the actual algorithm, we're only looping through nums once. We're not looping through it like n squared times to check every element or anything like that, because like as we're increasing the right pointer, we're also increasing the left one along with it. So overall, the runtime still ends up being only O of n. I know it's like kind of confusing, but yeah. And then the space complexity is just O of 1 because we only have like some variables here. We don't have any data structures. So that's it for this problem. I hope it was helpful. And if you have any more requests, drop them in the comments. Let me know what I should do next. Thank you.